So I'm a PhD candidate here at UTS in the Centre for Quantum Software and Information, but I also have a background in economics and I'm also a lawyer for my sins. My work as a data scientist is in politics, so I'm the guy that builds the models for political parties, but I don't do that anymore. And today I'm going to be talking about the impact of some issues in computational science on ethical algorithms. And apologies for people that may have seen some of this talk before. This is ongoing work which is ultimately going to be a paper at some point. So the talk's about what we can and can't do from a computational science perspective. People talk a big game in this area. It's quite hyped. People have a bit of a dark default when it comes to data and computation. You know, people watch Terminator 2 and so on, and they sort of think that, you know, the big bad tech is coming for them. And there's this idea that government or us collectively, that we can respond, that we actually have both the tools and that it's computationally possible to build a regulatory system or to do the things that make us feel good or to ethically regulate. And what are we talking about is, as you'll see through the slides, is a way to frame what's going on when you're considering what's a computational response to ethical challenges. So what is an ethical algorithm? How do you classify it? What are the procedures, if you like, that may be involved? And we've heard a great case this evening of an applied case. And then I'm really going to focus on the 4 C's, which are computability, consistency, complexity, and controllability of the systems that you may wish to implement. Thanks. Sorry about that. So I'll be talking about some of these things. I'm just going to skip across. So the basic proposition of what I'm talking about this evening is that if you take a step back and you look at, well, what would a regulatory system look like where you've got 100 million neural nets working at any one time? So many that you can't even, from a regulatory perspective, classify what's actually going on. You've got different views on what moral standards should be. How on earth could any country, let alone the whole world, deal with this challenge? Again, people talk about it as if we can pass a law and force coders to do something, but in reality, I just don't think that's ever going to be the case. And so my argument, the proposition I put forward, is that due to the complexity of the role of data and the role of computational processes, that in order to check whether either the algorithms that you are using or the output of them meet some ethical criteria, you need another computational means to do this. Humans can't and never will be able to really check, in my estimation, whether or not all these rules are being complied with. People have talked about the case of Compass. I'm not sure if the Compass case has been talked about recently. So that's a case where there was a recidivism predictor. And so the question was whether that was adversely impacting African American men in a way that it wasn't adversely impacting non-African American men. And that's fine to talk about in that particular context. But I think if you have many of these algorithms running at any one time, then the idea that you can somehow classify the algorithms as doing the wrong thing is going to be very challenging. So the basic idea, things are too complex for humans to do it. Therefore, in order to achieve the ethical outcomes that we want, we need a computational response. And I say this also because I have worked in politics and I don't necessarily trust our political class to get it right. However, because the response is computational, it means that what we know from computational science, as I'm sure many people here know, is going to put a limit on what we can actually do. So again, I guess my argument is to maybe tone it down a little bit in terms of what we can realistically achieve. This means that obviously, as we all know and love in computer science, we have to fall back on heuristics. We have to maybe get comfortable with probabilistic reasoning. Is our algorithm probably anti-discriminatory or not? Are we comfortable with the thresholds? So I'm going to briefly skip through maybe some of the framings of what I'm talking about with an ethical computation. So what does it mean for an algorithm to be ethical? I frame this in terms of ethical computation. So if you like, there's ethical means. So again, have you used a class or an attribute which you shouldn't in your computation? Maybe you've used race, maybe you've used gender. And then there's a question of, is the outcome meeting some ethical criteria? A very popular one is equality of false positive rates. And I sort of call this a form of algorithmic consequentialism. And then this other issue of how do you audit what's going on? If you had to walk into a bank or Google or Facebook and you were tasked with checking whether their computational systems met these prescribed criteria, how on earth would you achieve that? Would you read through 1 million lines of code? Is that what you would do? Or would you have to build another system to check that code? It's not that simple. And if you go through the literature, people are really focusing on this. So again, reiterating the point, ethical AI problems are complex. If you look at our financial markets, they are too complex for humans to regulate properly. So anyone who's probably heard of the flash crashes and so on knows that in order to regulate those technological means, we need another form of technology. And this is, for example, what the SEC is looking at in the States. My contention is that as other forms of social interaction start to look more like what we see in the financial sector, as in high volume, high velocity of transactions and judgments, again, we need a computational fix. Hence, we need algorithms to do the regulating. So I say, this isn't my phone. So I want to present here a bit of a framework for people in computational science. I'm not going to go through what computational complexity is in much detail, but this is a bit of a framework to try and provide a bit of a taster as to some of the computational concerns that people need to think about. One is computability, the second is complexity, third is consistency of your algorithmic system, and the fourth is controllability, something close to my heart because I do a lot of quantum control. We can't really control quantum computers at the moment. Computability and efficiency are two questions that we should talk about. So is the ethical computation, so is the procedure or outcome actually computable? People might say, I want this ethical outcome and I want this other one, but it may not be computable. There may not be a decision procedure to actually work out whether or not you have reached that outcome. Now, I would like to think that that's not really going to be a problem for many use cases, but we don't always know because we don't always know how inconsistent our competing ethical objectives are. Can you do the computation in an efficient way, given your resource constraints? AlphaGo took a lot of energy, for example, to sort of beat the world's best Go player. How much energy would it take to audit AlphaGo? And then audit other computational systems? It might not actually be something that we actually can do. And so this needs to be thought about when we're trying to build a regulatory framework. I'm going to skip through this. This is just what I was talking about. There's issues of computational complexity, and if you look at the fair machine learning literature and elsewhere, people are trying to grapple with this issue of answering these questions through computational means. Are they too complex? So computational complexity, again, for all the computer scientists, they'll know this, but for those that aren't, this is this is a concept that looks at what are the resources needed to computationally solve a problem as it scales with input size n. So an efficient computation is one that you can do in a polynomial function of n. And an inefficient one is, so that means as the input size grows by one, does the amount of time it takes, is that a polynomial function, so x squared or something, or is it an exponential function? If it's the latter, each step you take forward, the answer gets further away, and that means you actually can never find an answer. And then again, do you have the resources to do the computation, even if it's not in a high complexity class? There may be computations which are in P, but it might take 1 million years to do, so effectively they're not reachable for us. I'm going to skip through this. I'm sure we all know about this. Then this is a question of, if we build a regulatory system that is there to regulate algorithms, audit them, how consistent does it need to be? And what does that mean? Is consistency meaning that, for example, process consistency? Does it mean that all decision procedures are consistent? Should similar decisions follow similar means? And this is important, if you're building a neural network or any other system that is a black box and it's trying to learn an arbitrary function, you don't necessarily know that it's actually learning the same function time and time again, given slight tweaks of input data. Maybe this doesn't matter. Maybe that's because you say the criteria to audit the algorithm is outcome consistency. And this is very common in the fair machine learning world. So these are two challenges. I'll skip over there's this other point that I have been thinking about recently, which is how comfortable are we when our algorithms, say we want to build an algorithm and it actually tells us that our cherished truths are not as ethical as we once thought. Are we comfortable with our algorithms pointing out things that we don't want to hear? It's a big, I think it's an important question. Finally, controllability. Can we actually control the algorithm? I'll skip through control theory, but the kind of issue here is, particularly when we're dealing with a black box means, how do we control a system which is a black box from our perspective? I'm going to skip through all this open and closed loop control. I want to quickly skip to, sorry, there's too much here. So just on this last point for controllability, the classic case is, let's build a neural network to classify X. X might be whether you get a loan at a bank. Let's take out race. So in our feature column, race is gone. So there are ways to do this. But as someone from Google was pointing out at a conference I went to earlier this year, they have algorithms that re-engineer the protected class back in. And you don't necessarily know that this is the case. So it's not necessarily the case that taking the feature out, race, gender, so on, necessarily means that the black box is not reconfiguring that protected class in another way. As in, you can't necessarily control what's going on, and this poses challenges for regulation. So in conclusion, computational limitations and impossibility results, which I haven't touched on, are important. Let's not just have this naive idea that we can go out and pass a law that says regulate, your algorithms must do the right thing, because I'm not even convinced that it's necessarily technically possible. In most cases, maybe someone will convince me. Consider the 4 C's when you're looking at the design and regulation of ethical algorithms, or RegTech, in order to impose ethical states. And maybe take, and I think we heard earlier, take a leaf out of some existing systems where we try to regulate our society, such as the law. So the law is not a consistent system, I know, any lawyer knows that, but the law functions. It functions pretty well in this country, and I think there is inspiration that we can take from systems that are not particularly computational and see, well, how can those features be brought into a reg tech scenario. And I'll leave it there. Thanks.